Roll number 276 just texted me that there's some network issue, so she couldn't responded her roll call.
You please write it in the chat box. Later I will mention. Okay. Please,
Okay.
right now I am going to discuss this one. Okay, so in my last class, I have already discussed with some total title of the experiments, what experiments we are going to be performed. Okay, that we have already discussed. So normally we have using that NI multisim platform. Okay, so I hope all of you have installed it to your computer or laptop. Okay, so you can do that simulation smoothly. Okay, so here what was our first experiment, simulation experiment. So the title of the experiment I have already discussed, that analysis of single phase half wave diode rectifier using different types of load. Okay, what are the different types of load? That is your R load, RL load. Okay, RLE load with freewheeling diode, RLE load, and RL load with freewheeling diode, RLE load, and RLE load with freewheeling diode. Okay, this is very simple experiment. Okay, for this one, so first when you are preparing your document, okay, this is just for an reference. Okay, it's not like that everything will be when you are preparing your document, it should be very well uh, well written and well documented. Okay, basically it's a simulation lab, and whatever resource if you want to use, I hope all of you have take the preparations. Basically today we are going to conduct one MCQ test. Okay, after discussing these after discussing these simulations, after discussing this experiment. Okay, then what you need to do, you have to simulate it to your hostel. Okay, after that in my next class you can show me the what was your simulation and you submit your report. Okay, so that's the normal pattern for every day, and after completion of 2 lab, okay, we will conduct some Viva versus today. Yeah, today we are going to discuss about experiment number 1. So in next week we are also discussing about experiment number 2. Okay, then that the next week what happened, after discussing of that experiment number 2 and after checking your report. Okay, online I will check it. Okay, all of you prepare it online. I will check it. I will ask any of you randomly, and I want to ask you to please show your simulation as well as what report you have prepared. That I can that every day I will ask you. Okay, and next week number 2 experiment will be there, so that's why one viva will be there. Okay, so after completions of the experiment, then MCQ test, after that the viva will be conducted. Okay, that's the normal pattern. After completion of 2 lab, we will conduct one viva. Okay, suppose then which day we are going to be discuss about experiment number 4, that the second viva will be there. That viva will be based on your first and second experiment. If that viva will be there based on your second, third, fourth, like that it will be going on. Okay, normal continuous evaluation process. Okay, so here you can see analysis of single phase half wave diode bridge rectifier by using different types of load. Okay, so single phase half wave rectifier. So means you are going to be rectifying only one cycle. Okay, and you are using only diode bridge rectifier. Oh, another important issue thing that I will share this document with you. Okay, so it's a randomly prepared document. Okay, some mistakes may be there or may not be. Okay, so if there is any kind of mistake, you please raise your point. Okay, and you can rectify it for your own write-up. Okay, maybe there. Okay, so maybe some mistakes may be there. Basically, very fast we are doing everything, na? So maybe some mistakes may be there or may not be. Okay, high chances there will be no mistake, but if there are any mistakes, so please rectify from your end and let me know. Okay, so I can also correct some of the point. So here you can see that what you need to write for your report. So first objective of the experiments, or you say like that aim of the experiments. Okay, then theory, basic theory is very simple. So theory, procedure. Okay, so you are using simulating that NI multisim platform. So theory is required. Okay, so the theory portions I have given only very small brief theory, but I'm expecting that you will give some elaborate theory. Okay, with proper circuit diagram. Okay, so basic circuit is there for the simulations, but some circuit is required for this for this theory also. Okay, the circuit, suppose here you are using some single phase AC, then it will be passing through like that. You can see the diode is there. Okay, so here you can see diode is there. Okay, in the theory, then then diode is there, so there is a single phase voltage. Okay, and you are rectifying the diode, you will get that output across your resistance. Okay, that voltage will be there. Okay, so here we are using some digital voltmeter, ammeter. Okay, whatever you can use. So this is single phase one. So here you are using simulation. So this is NI multisim circuit. Okay, so you have to give some figure number. Okay, figure one is the circuit diagram of your halfway full bridge rectifier with unload. Okay, the specifications are already given, that it is your voltage specifications, like RMS voltage is 100 volt, DC offset 0 volt, frequency 50 hertz. The specifications also given. So then whatever transient analysis configuration means how much you want to see that one. Okay, so here you can see that analysis and simulation. That part you have already did it in your NI multisim circuit class. Okay, so I am not going to I think okay. The specifications and configurations are given here, so you can give it, you can put all those values over there to see your response. Okay, then you want to see that value. How do you see the waveforms? How it will be coming? So transient response is there, so you have to select. Okay, ID1 means ID1. You can see over there. It's your diode current. Okay, so D1 is your diode. So ID1 here you can also see from the ammeter. From the ammeter you will get it from ID1. Okay, so ID1 is there. You can select whatever. You can see IV1. So all the things are there. Power you can also fetch. Okay, so I1, that variable is IVV. Two variables are there based on your nodes. Okay, suppose in the voltmeter is connected in your source side, one voltmeter is connected to your load side, and current is there. You can add over there, so you'll get it. Then save and run. So here you can see the input voltage are coming. So you can also connect the trace. Okay, how much values are there, cursor. Okay, you are connecting the trace or cursor to getting that how much voltages are there. Okay, so from here you can easily understand how much voltages are there. Okay, what is the peak voltage? Okay, so as it is coming, so you have to cross check it. Okay, so you have to cross check it. So whatever values you are given, okay, so whatever values you are given this table, that input voltage configurations. Okay, so that value should be coming from here. Okay, that's cross checking. If you need to do the cross checking, that cursor here, you can see the cursor, that value should come here. Okay, so then load voltage, this you can see how much peak. So it is it coming the exact one? Okay, then load voltage you can see, so it is half wave, so only one cycle, half wave diode bridge rectifier. So if it is control rectifier, then you can, if you vary the firing pulse, so that response has also been varied. Okay, so half wave means you are giving only one cycle. Okay, so every point, so but another cycle you are not getting. Okay, so how much load voltage? So you have to prepare a table. Okay, so you have to prepare the table by changing of your firing pulse, but here the table is not required. Basically it's uncontrolled. Okay, so if it is controlled, then the one table is required. So it is uncontrolled, no tables are required. Okay, so here you can see that output. Okay, so finally the load currents. Okay, you can see the magnitude, that voltage divided by resistance value, how much resistance you are connecting here. Okay, that resistance value, so you will get that you will get that current value. Okay, so this is voltage waveform, this is current waveform, magnitude. Okay, so how much values are there? So almost you are using resistive load, you are using the resistive load, so voltage and current both are in phase. Okay, so both are in phase, there is no such differences over there. Okay, so it's a simple one, and what you can do, it's a simple one, and current and voltage are in phase. So here you need to write a comment. Okay, here No, you can also write here comment or conclusion section. You can also separately you can give a comment. So discussions, you need to do the discussion. What discussion you have observed from the waveforms. Okay, so discussion portion is not written over here, but you have to write the discussion portion. Okay, so am I audible from your end? Am I properly audible from your end?
Yes, sir.
Okay. Acha, Amrit, Anesh, Amrit, am I audible? Amrit, Amrit. Amrit. Okay, so here you can also here you can also see that how it will be distributed. Okay, then some discussion portion is required, but this discussion portion is not written over here. Okay, then single phase half wave diode with RL load. Okay, so now that circuit connections, these all are the simulation, but in theory you have to give some brief idea about all the circuits. Okay, so R load, what will be that? The theory portion is written very brief manner, but it should not be like that. Okay, so you should write it in elaborate manner with proper circuit diagram. If RL load is there, what will be the theory, what will be the some mathematical expressions. Okay, so that you need to write, but it's not like that you are copy paste from any downloaded resources. It's not like that. If you copy paste from this document also, so it is not acceptable. I am expecting that you will do it by yourself. Okay, so at the date of final experiment, I'll ask you to every day I'll ask you to run your simulations. Okay, and not possible for 49 students, but randomly I'll ask, please run your please simulate it so I can see your results. Okay, as well as you need to provide the documents. Okay, so theory portion is there. So based on your different load, you have to write the theory. But in simulation section is more important. So where you need to write the, you have to provide the waveforms, then discussions. What you have observed from these three diagrams. Okay, 3 meters are there. That's why 3 diagrams are coming. Okay, simulation diagram. Then circuit configurations. Here you can see. So it's a power diode. Okay, you can see like that Moore 420 is used. Okay, so Moore diode is there. So what is your voltage specification? Your voltage specification is 100 volt VRMA. So based on your specification, you can select it. Okay, so R value is given. So 100 ohm and L1 is 0.5 Henry. Okay, so and how much voltage you are obtaining over there. Okay, output voltage that you can also calculate. Okay, by digital multimeter. So input voltage configuration is almost same like your previous case. Okay, so input voltage configuration, transient analysis, that also same. Okay, then what waveform you are going to see, that is also same. Okay, so now waveform of input voltage definitely same. That load voltage, how it will be like that load voltage. Okay, so here you can see some of the transients are there. Okay, and load current, it's a diode, so no negative current will be there. Okay, so it is when you can see in first case that current is zero. Okay, first case the current is zero up to that point, that 0 point. Okay, but here you can see the current is not zero up to here, so it will take some time. So current will zero up to reach over there. Okay, then single phase half wave directed with freewheeling diode. If you include some freewheeling diode, so what happened? That point will be zero. Okay, so you can see you can change that one. So if you see the waveform, that point will be zero. That negative voltage is coming like that portion, it will be zero. There will be and current also been extended. Here you can see it will sometimes, so freewheeling points are there. Okay, like that you will get the waveforms. Then RLE loads are there. Okay, by using that RLE load, what will be the waveforms? The values are given: 100 ohm, 0.5 ohm, and 1 volt. Okay, all the values are there, and here you can see here you can see the specifications. Okay, that you are using Moore diode, Moore 420. You can cross check it to the type it the what I can say. So batch number to the Google. Okay, so you can also see that how much ratings are there, how much voltage and current ratings. So based on your input voltage level. Okay, so we have to select the diode. It's not like that only you can see that mode for 20. Okay, you can also change it. Okay, you can also change it, no problem from there. So for it's your RLE load. RLE load means whatever there. So if you see the output voltage, some bias value. So E value will be there. Here you can see. Okay, so some E value will be there, and you can see with having more or less if you use that waveform, so directly you can see the current waveform also how it will be look like that. And finally if you using freewheeling diode, so so if you are using the freewheeling diode, so what will be that value? So that value will be 0. Okay, here you can see that freewheeling diode value. Okay, you please cross check it, the RLE load with the freewheeling diode, the responses for the RLE load. Okay, so please cross check it. So sometimes what happen, NI multisim also operated some error, sometimes some error will be shown. Okay, some error will be shown like that, sometimes simulation errors. Okay, so you have to cross check it. Most of the time it will not come, but if it is come, so the specifications, the values, the selection of the switches, suppose what happened, sometimes what values you are selecting, but by that value the circuit is not properly working, it is burning out. Okay, at that time we will face that kinds of error. So selection of the component is very important. Okay, so which value you are going to use, that is very important value, that is very important. And after that finally you have to write the conclusions. Okay, so what is your conclusions? So individually for R load, RL load, RLE load, what kinds of configurations, what kinds of conclusions you are getting, that you must to write down. Okay, so conclusions also important. So for freewheeling that, here you should write, so why you are using the freewheeling that. Okay, and RL load, RLE load, is there any differences of their applications? There may be some differences will be there. Okay, so what kinds of changes you have observed? Okay, for RLE load, if that value is very less, okay, so in that case what happen, if you increase the one study you can do. Okay, here you can see only 1 volt is there, RLE, only 1 volt is there. Okay, so based on that 1 volt and your input voltage is 100 volt RMS. Okay, so you can see that configuration, that voltage value is very less. Okay, so if you zoom here, so you can only see that value. Okay, so that voltage values are very less. So what you can do, you can change that E value. Okay, so you should prepare one table. Okay, where you are varying. Okay, so you should prepare, the table is not there, but I am telling you, if all of you please noting down. Okay, all of you please noting down to your copy. Okay, so for RL load and RLE load, okay, what you need to do for RL load, you can change that inductor value. Okay, here only 0.5 Henry inductor values are there. So what you need to do, you increase that inductor value. Okay, suppose 10 frequency means 10 sample you are taking. Okay, suppose one you have considering zero point 0.5 Henry, then 1 Henry, then 1.5 Henry, 2 Henry, then 5 Henry. That is your positive side. Okay, and 0.5 Henry is your standard you are considering. Now you are in decreasing the value. 0.5 Henry is there, then make it 0.25 Henry, then make it 0.1 Henry. Okay, then make it 0.01 Henry. What changes will be there? You can see lot of oscillations will be there. Okay, so lot of oscillations will be there here. Here you can see lot of oscillations for inductor. Okay, there is a freewheeling diode, you cannot understand so much. Okay, that one study you can do. And what you need to do, prepare a table. Okay, prepare a table. Okay, so by changing of the inductor value, what output voltages, magnitudes are same or different. Okay, and waveform. Okay, that you can crop this waveform. So output voltage waveform is there. Okay, this is your output voltage waveform. Okay, so all the time you simulate it and you will get some waveform, and in that table you paste that waveform. Okay, so for changing of the inductor value from very less value to very high value. Okay, and how the waveforms are changing. Okay, and side by side, what is your RMS voltage. Okay, what is your RMS voltage? It's a DC output, so you can select the what is your average voltage in output side. That voltage is increasing or decreasing. Okay, that you have to study. Okay, that table is not given here. Okay, that's why I'm telling you to note it down to your copy. Okay, to your copies. When you are simulating, you please prepare the table. Okay, that is number one. Number two, what is number two? The for 0.5 I am telling about your RL load. Okay, so RL load you see that study. Okay, for RLE load, okay, so what you need to do first, you have to change that E value. This is back in normally RLE load, that E is considering that induced EMF. Normally motor load we are considering for the RLE. Okay, so if you change that value of E, how your output voltage is changing. Okay, suppose here you are using that inductor value. Okay, so here you are using that RLE load without freewheeling diode. Okay, RLE load without freewheeling. If you decrease the value of inductor, okay, so what happened? You can see more oscillations. Okay, that ringing effect, that is called ringing effect, more oscillation over there, more oscillations. Okay, that I need to see what kinds of response are coming. Okay, I hope all of you are able to understand what is my agenda to study for this one. Okay, if you change that inductor value, what kinds of changes are there. Okay, and you can see more or less it is coming nearer to zero. No, it is not exactly zero. Okay, why it is not exactly zero? So E value we are considering how much? Here we have just taking E value is 0.1 volt, 1 volt, and your RMS value and output value is more or less 70 volt or 1 volt. Okay, so that value is very much less. Okay, that 1 volt compared to your output voltage, it is very much less. So that's why it is you cannot see. So what you need to do, you increase it. Okay, so first check it for 1 volt, then make it 10 volt, 20 volt, 30 volt, 50 volt, 60 volt. Okay, and up to 100 volt you can go, and let's see what kinds of response you are getting and what is your output voltage. So again you need to prepare a table. Okay, so for RL load, you have to vary that inductor value. For RLE load, you have to vary the first vary that E value. Okay, increase the value of E. Okay, then what kinds of response you are getting. Okay, and you are using digital multimeter. Directly you can fetch that data. Okay, so one table you need to prepare. Okay, one table you need to prepare by changing of E value of RLE load, what responses are coming. Okay, so first provide the circuit diagram, sorry, first provide the waveform, output voltage waveform. What kinds of changes are there? Okay, what kinds of changes are there in this case, in this waveform, that I need to see. And another column will be there, that is your average voltage, average output voltage, when load voltage, what voltage are there. Okay, so changing of the E value. So that you can see. So up to input voltage is 100. So you can go up to 100 volt. Let's see what happened. And if you making it more than 100, then what will be the observations? So that simulation is very basic thing that anybody can do that simulation. That's a very simple simulation. The main concept is that how with the changing of any of the parameter your system is behaving. That is our main agenda for doing this lab. Okay, that basic thing all of you get it from the book. Okay, there is no meaning for there is no meaning to replicate. Definitely there is a meaning to cross check whatever theories are there, it is coming or not. That is number one. For experimental way, sometimes what we can do for experimentation, we are not able to see all those responses. Okay, it can also possible in experimental manner, but that is not possible right now. So what we can do in simulation, we are changing the parameter value and see how the values are coming. Okay, that is our agenda for this lab. So whatever we are going to perform here, okay, so that should be crystal clear. Okay, so in future some of you are get benefited. Okay, to develop your concept. Okay, that's the agenda of this lab. Then inductor E value we are changing, so you can see that shifting will be there gradually. Okay, so here only 1 volt, that's why it's look like only nearer to the zero, but exactly it is not zero. Okay, so it is some values are there. Okay, so if you increase it, so gradually you can understand. That is number one study, and you have to plot that one. So x-axis, what is your variations, E value is there, and y-axis output voltage. So you can use some Excel plot. Okay, some Excel, you can plot it, or you can do Excel, you have to put this value and what kinds of waveform you are getting. Means table. From the table you can draw some, it's, you can say like that, it's a what waveform you are getting with the changing of that E value. Okay, suppose 10 sample you are considering and 10 output voltage you are getting. Okay, how much that waveform, how it will be look like that? You are getting my point? Okay, so in same case, changing of the inductor also be done in that RLE load. Second case. Okay, so make that value very less, 0.01 to up to 5 millihenry. Okay, your zero point 0.5 millihenry is standard, but it's not like that. 0.01 millihenry circuit may not be run. Okay, so why? The basic concept will be there. Why, and why it is not running? The concept is that sometimes what happens, that ripple, you can see lot of ripples are there. Okay, by very less value of inductor, lot of ringing effect will be there. Okay, that may cause the damage of your switch. Okay, that's why sometimes you can face the error. Okay, so at that value of less value of inductor, you can see like that one error may come, that consecutive zero crossing. Okay, so circuit is not run properly. That error you may face. Basically, the circuit, why it is not running, the switch, what specification you have considered here, that is not working properly in this value of inductor. So specifications of the switch also very important. It can be run, but in that case you need to change the switch. But our agenda is not to change how much, only see at which durations, that zone of operation we can also see. Fixing of the switch, no need to change the switch. Suppose 0.01 Henry, it is not working. Okay, make some more value. Okay, and go up to that 5 Henry, taking 10 samples, just below 5 samples of zero point 0.5 Henry, and just below another 5 samples for just above zero point 0.5 Henry up to 5 Henry. Okay, so that's the range you can see over your simulation. Total 10, 11 sample will be there. Again, output voltage. Okay, we are using digital meter. So how much output voltage you are getting? Okay, then you have to plot it in the curve. Okay, so that kinds of study you have to do. This basic simulation will be there, but that table I have asked about 3 tables for RL load and RLE load. Okay, that's RL load 1 table by variations of your inductor, first table, and how the waveforms are changing and what is their average voltage. Then fixed one inductor value, now vary the resistance value. How your average voltage is changing? Is it changing or not? That another table. Okay, and you have to plot that changing of that R value, how the R output voltage is changing. Okay, that you have to plot. Same thing also there for the inductor. For RL load, 2 table as well as the 2 additional chart will be there. 2 additional diagram will be there. Okay. For RLE load, another 3 tables, basically variations of R, variations keeping other values are fixed. Okay. Then variations of L, keeping other values are fixed, and finally variation of E, keeping other values are fixed. What was their values? Okay, E value in the table, what you need to provide, E value, then what is your waveform, and what was your average value. Then you have to plot it. Okay, in your Excel file. Then paste the diagram. X-axis, Y-axis you must mention. Okay, all of you getting my point? Any confusions from your end? Hello, Vishwajit.
Sir, one confusion,
Yes, sir.
sir. How many
One by one, one
have
by one,
to
one by one. First, Vishwajit, tell me.
No, sir, not.
Ask me what confusion. Tell me.
No, no confusions.
Acha, acha, who is asking how many one
sir? Yes, sir. Sir, how many samples of each table we need to do? Five,
that
three.
is in your hand. That is in your hand. Okay, Shakti. So my motivation is that I am telling. So suppose zero point 0.5 is design value. Okay. So what we are doing in actually when we are fabricating the power electronics circuits. So first we have to design it. Okay. It's not like that arbitrarily we are picking the value. But in simulation we have that independence that we can pick any of the value. But problem is that we are using NI multisim platform. Okay, or you can use also PSCAD, you can also use the PSteam, you can also use the OrCAD PSpice, that type of softwares, not like in MATLAB. Okay, not like in MATLAB. MATLAB also facing, in that case, MATLAB, they are giving quite generalized value. Most of the time it will run. Okay, but in case of this type of software, they are having some database that is actual database of your components. Okay, suppose suddenly you are varying that duration you are asking about, that very less value means that may not be that by that value of resistance or inductance, it's also possible circuit is not running. So this is up to you. Okay, so you can see some selection of the boundary or selection of the parameter, maybe some drastic. Okay, suppose you are using zero point 0.5 and I am telling about 5 Henry. So how much variations are there? 10 times variations in your parameters, suppose in load end. Okay, another variations I am telling that 0.01, another and your rated value is 0.5 Henry, and I am telling about 0.01. More than how much variations are there? I think more than 100%, 500%. Am I right, Shokti? Is it 500 or 50, 50 times? I think so.
Yes, sir, 50 times, sir.
50 times. So that drastic changes I am asking, but it's not like that the switch will work at that drastic changes. Okay, so you have to specify it. So and selection of the parameter should be like that when you are plotting the graph, so it should be distinguished. Suppose 0.5. Okay, you can also be zero point 0.4, but what happened? The response of the 0.5 with your circuit, the response of the zero point 0.4 Henry with your circuit more or less same, basically 0.1 variations. So that's why you can see like that you may take zero point 0.5, next one maybe there 0.1, at least 1/5. Okay, then another 1/5 you can also take. So based on that, so based on your simulation is running or not. Okay, that's the basic thing. So sample will be more. Okay, your report will be more pages, but you can see some significant behavior of your circuit. That is more important in this, that is more important in this class. Okay, so what kinds of significant changes you are observing? Okay, so that's the basic motivations. Okay, any other queries from your end?
So one thing, sir, if we make a table about it,
Hmm.
then those values on the graph won't be much visible. Only the waveform is, I guess.
Only waveform, that specific one big waveform will be there for understanding, for the case of understanding, and that when you are plotting that small waveform in that table, so most of the thing is not visible properly. You are right. Okay, but make it in landscape where you are putting those table. Okay, make it in landscape. So somehow some of the area may be managed. Okay.
Okay, sir.
Yes. Any queries from Ashwini?
No, sir.
Okay. So, Komal, any doubts from your end? Komal Krishna Behera?
Yes, sir. No, sir. No doubts.
Acha, Lakshmi?
No, sir.
Okay, so most of you have no doubt, I think so. So next class we can see how much simulation you are performing and the report. Okay, that randomly I asked all of your name and I want to see. Okay, so okay, so today I'll discuss up to these portions. Okay, so I think you can you can simulate it.